Hi YouTube, Tim Eckert here. In this video, I'm going through my Algebra 1 honors do now for the day. This is like a warm-up, and this video for people who aren't in my classes, this is basically taking tables and writing functions based off the tables, and these are either linear or exponential functions. So let's start. Consider the table below, write a function based off the table. So first off, let's look at how much we increase each time and if it's a constant rate of change. So going from minus 10 to 10, that's a jump of 20 up, so plus 20. Then from 10 to 30, it's also plus 20. 30 to 50, 50 to 70, and 70 to 90 are all jumping by 20. So it's a constant rate of change, and if we're going to write a function with a constant rate of change, we're writing a linear function. So it's going to be of the form f of x equals m, which is the slope, times x plus b, which is the y-intercept. So this is the slope. This is the y, or f of x, intercept. Let's see if I can fit that all in here. Intercept. Okay, so the slope here, we're increasing by 1 on x each time, and we go up by 20 on f of x, which is like y equals f of x. This is going to be our vertical axis here. So our slope is 20. So we're going to start with this function f of x equals 20x. And then we've got to look at our intercept, and that's where x equals 0. And in this case, our intercept is negative 10. So we could do plus negative 10 or just minus 10. And I think minus 10 is cleaner. So that's our first function, f of x equals 20x minus 10. Okay, let's look at the second problem. Okay, write a function based off of the table below. Let's take a look at the change here. So we go up 10, then we go up 11, then we go up 12.1. So this is telling me that we probably have an exponential function here. Okay, so let's clear that out. So the exponential function is going to take the form f of x equals a, which is the amount when x equals 0. Sometimes it's referred to as a constant, times the base of the exponent b to the x power. So this could be a growth or decay factor as well, and this could be an initial amount if we're talking of like some type of biology. So the initial amount in this case is when x equals 0. So a in this case is going to be 100. And to find the growth here, because it's increasing, so it's the growth, we're going to take 110, we'll take the second value, and divide it by the first value. And that'll tell me how much we're multiplying by each time as we go up. So 110 divided by 100 is 1.1. Now if I multiply 110 by 1.1, so we do 110 times 1.1, we'll get 121. If we multiply by 1.1 again, we'll get 133.1, and so on. Okay, so our function here is going to be f of x equals 100 times 1.1 to the x power. Now you could also use the mit dot here. I like the parentheses to indicate the multiplication, but to each their own. And that's our function there. Okay, let's look at problem 3. What function is represented by the table below? Okay, so let's look at the change here. So we actually go down 30 here. And we go down 30 again. And each time we're going down 30. So it's a constant rate of change. And as we go up 1 in x, we go down 30. So this is going to be a linear function, and our slope is going to be negative 30. Now you got to be careful here, because you might just pick the first value here and say, well, okay, that's for the first value of x, so my b value is 30. But that's actually not the case, because x equals 1 here. So if we thought about what the amount would be when x equals 0, we'd actually have to go, because it's going down 30 each time, we'd have to go up 30. So we'd start from 30, add 30. So our intercept here would be 60. So our function is going to be f of x equals negative 30x plus 60. So that's our function for that one. Okay, let's keep going. Let's look at problem 4. We're considering the table below, and we're writing a function based off the table. So I'm looking, as I go up, like the change here, if I take 133.126, I'm doing a calculator here, 875 minus 126.7875, that's 6.33. But if I take 139 and I subtract 139.78321875 and I subtract 133.126875, I get 6.65. So we don't have a constant rate of change, so this is going to be an exponential function. We can take this 133 and divide it by 126. So if we do that, so 133.126875, divide that by 126.7875, and we get 1.05 as our b value here. So 1.05. But now our initial amount, we notice that x equals 2. We want to figure out what the initial amount is when x equals 0. So what I would do is I would take the 126.7875, divide by 1.5. That'll give you when x equals 1. And then divide by 1.05 again, and that's going to give you when x equals 0. And if you divide by 1.05 twice, you get 115. So we can say f of x equals our initial amount, 115, times 1.05 to the x value. Okay, that's my function for that one. Okay, let's go to problem number 5. Consider the table below, write a function that models the data in the table. So I'm jumping by 4 here each time, it looks like. So it's a linear function, constant rate of change. My slope is going to be 4. But I don't know what b is going to be. Okay. So x is starting at 4. So if we go down to 3, we're going down to 106. Then we go down to 2, that's 102. Then 1 is 98. And then when x equals 0, b is going to be 94. Okay, so b is going to be at 94. So my function f of x is going to equal 4x plus 94. Okay, last one. Okay, we're going to use the table to write a function. So let's see, this one we jumped down about 13, a little bit less than 13. This one we jumped down a little bit more than 9, and then we jumped down a little bit more than 7. So it's not a constant rate of change. So I'm thinking exponential function. So let's find out the b value here. Let's divide this value, 37, by 50. So b is going to be less than 1. So we'll take 37.546875 and we'll divide it by 50.0625. And that'll give us 0.75. And to figure out our initial amount A, we're going to have to start with the 50.0625 and we'll divide by 0.75 twice. And that's going to give us 89 for our initial amount. So our function for this last one is going to be f of x equals 89 times 0.75 to the x power. And there we go. If you have any questions on these problems, leave a comment in the comments below. And if this helped you out, give a like and consider subscribing to the channel.